Hi children, this is Murthy and you are watching 10th class mathematics, secants and tangents to a circle, part 1. Dear children, this lesson, secants and tangents to a circle, is in 10th class mathematics paper 2. You can get nearly 10 to 12 marks from this chapter in public exams. So concentrate on this lesson. Children, do you know what is a circle? A circle is a set of points which are at a fixed distance from a fixed point. Now, just recall what is a circle and what are the basic elements of a circle. Just look at the circle. You know, center, radius, diameter, chord, secant, tangent, and some more are the basic elements of the circle. Children, have you ever observed when you are bicycling? The wheels of your bicycle are in the shape of a circle, and when you are bicycling, the road touches your wheels and it looks like a straight line touches the circle. Now, let us learn some topics about the straight lines and the circles. Children, in a plane, take a circle and a straight line. Now we can find what is the relationship between the straight line and the circle. In case 1, a straight line passes through the plane and it does not intersects or touches the circle. Now this straight line is said to be a non-intersecting line with respect to the circle. In another case, if the straight line cuts the circle in 2 points, that means the circle is intersected by the straight line at 2 points, then the straight line is called a secant to the circle. In third case, if the straight line touches this circle at 1 point, then the straight line is called a tangent to the circle. If the line touches this circle at 1 point, then the line is called tangent to the circle, and that particular point is called as point of contact. Children, do you know who introduced the word tangent and how the word tangent came? The word tangent was derived from a Latin word tangere, which means to touch with. The concept of tangent was introduced by a famous Denmark mathematician, Thomas Finke. Mr. Thomas Finke used the word tangent in earlier and developed the concepts of the tangents. Children, now let us learn something about the tangents and the circles. Children, we know that a circle divides its plane into 3 parts. First one is interior of its circle, inside of the circle. The second one is on the boundary of the circle, and the third one is outer part of the circle or outside or exterior of the circle. Now let us take a point A inside the circle. Can you draw any tangent to the circle? Let us try. Now the straight line cuts the circle in 2 points and passes through the given point A. It is not a tangent. So we cannot draw a tangent to a circle from a point inside the circle. Now take another case. If take a point A on the boundary of the circle, then try to draw a tangent to the circle. How many tangents can you draw from that particular point? Yes, we can draw only one tangent from that particular point. So we can draw one tangent to a circle from a point on the circle. In this case, if the tangent passes through a point on the circle, what is the angle between the tangent and the radius at the point of contact? The angle between the straight line and the radius at the point of contact is a right angle. This is the most important concept in this particular lesson. Now take the third case. A point P is located at the outside of the circle. Now, how many tangents can you draw to that circle from the external point P? Let us try to draw tangents. Oh, we can draw two tangents to the circle from an external point B. So, the number of tangents to a circle from an external point is 2. Now, let us discuss a small theorem about this concept. The length of the tangents drawn from an external point to a circle are equal. Here, the tangents AC and BC are the two tangents to the circle of center O. Here the theorem wants to prove that these two tangents AC and BC are equal in length. Let us try to understand this theorem by a small animation. Children, look at the circle of center O, and here P is the external point and PT and PS are the two tangents to the circle. Now here we can observe two triangles when we join the radii OT and OS. Here the two triangles are denoted by red color and yellow color. By taking these two triangles, we can easily observe that these two triangles are congruent triangles. In congruent triangles, the corresponding parts are equal. So, the corresponding parts like PT and PS are the lengths of the tangents. These are equal. Let us try to prove this theorem mathematically. How can we prove this theorem mathematically? Yes, we can prove this theorem mathematically by using a RHS congruency. Let us take the two triangles which were drawn by joining these tangents with radii. Here the two triangles are triangle OSP and triangle OTP. Now in OSP and OTP triangles, here OS and OT are the radii. OS and OT are the radii of the given circle, and angle S is equal to angle T is equal to 90 degrees. Why? Because the angle between the tangent and the radius at the point of contact is 90 degrees. We know it earlier. And OP is equals to OP, a common side. Therefore, by RHS congruency of triangles, triangle OSP is congruent to triangle OTP. Therefore, by CPCT property, SP is equals to TP. Therefore, the length of the tangents drawn from an external point to a circle are equal. Can we prove this theorem in any another way? Yes, we can prove this theorem by using a Pythagoras theorem. Pythagoras theorem states that in a right triangle, the square of the hypotenuse is equal to the sum of the squares of other two sides. Here, observe the right triangle. This here, the hypotenuse square is equals to side square plus side square. By using this Pythagoras theorem, we can prove that the length of the two tangents are equal. Let us see, how can we prove this theorem? In the earlier we said that the two triangles formed by joining the two tangents with the radii of the circle, triangle OSP and triangle OTP. Here triangle OSP and triangle OTP are two right triangles. In the first right triangle, in triangle OSP and OTP, first triangle OP square is equals to OS square plus SP square. In the second triangle, OP square is equals to OT square plus TP square. From these two equations, we can write that OS square plus SP square is equals to OT square plus TP square. Here, OS and OT are the radii of a circle and always equal. Therefore, OS square is equals to OT square. By cancelling OS square and OT square, we can conclude that SP square is equals to TP square. By taking the square roots on both sides, SP is equals to TP. That are the length of the tangents from an external point to a circle are equal. Children, now how can you find the length of a tangent? Here just take a circle of center O and take a external point P from a distance D and draw a tangent through a point A. Now the distance between the center and the external point OP is equals to D, and the radius of the circle OA is equals to R, and the length of the one tangent AP is equals to L. Now look at the picture. Here we can obtain a right triangle OAP. In this right triangle, OA is equals to R, OP is equals to D, and AP is equals to L. Now, by Pythagoras theorem, in triangle OAP, OP square is equal to OA square plus AP square, that is, D square is equal to R square plus L square. From this equation, L is equals to square root of D square minus R square. By using this formula, we can find the length of the tangent L is equals to root of D square minus R square.